All right. Hello, everyone, and welcome again to our Salt Security Founders Corner. I have with me today Roey Eliyahu, one of our co-founders. And the topic today we're really excited about. You're seeing a lot about it in the news. People have been talking about it for a variety of reasons, but it's about Gen AI. And we're going to dig into specifically how Gen AI is impacting API security. And maybe with that kind of broad setup, Roy, I'll turn it to you.
Thank you, MC. It's great to be here. Yeah, it's a very broad topic, so probably we'll need more than one episode to cover it. But maybe let's start with Gen AI and how does it impact API security? I think the reason why we started Salt about over 6 years ago, 7 years ago, was the movement from monolith application to distributed application through Kubernetes and containers. So basically, it was the concept of, hey, you break one APIs to hundreds of APIs of microservices that create really growth of APIs and have APIs be more dynamic, changing more oftenly. So naturally, you need discovery to know all your APIs. You need to inventory those. You want to govern them to make sure they are built with security in mind. And lastly, you want to protect them. But now there is a big compelling event in the market that if we were not starting the company 6, 7 years ago, I would probably restart it right now because that changed the whole game for APIs. APIs used to be built. They took days to weeks to months of coding and efforts to expose a new API. And with Gen AI, it literally takes a few minutes. So today's developers are being supercharged with Gen AI. It's so easy now to create a new application simply with Claude, ChatGPT, and you name it, Copilot and Cursor and many others that come into the market. And all of them made it super easy to create new APIs and to make changes to an existing APIs, applications in general, but APIs obviously is the glue. So now it's even worse. Not only that it's great for innovation, don't get me wrong, from a security perspective, even worse, because if it took you weeks to build a new API and still it was a wide problem in an organization, they have too many APIs to keep track of them. Now you have something that generated the code that it's not even the developer. The developer just prompt the LLM to help them build an API, but the LLM is not trained to do it with security in mind and definitely don't understand the specific business logic of the application, how it should be checked for security standards. So you have a lot of not governed code, not managed code that is being pushed to applications.
People are literally taking it, going to ChatGPT or whatever tool they're using, prompting it, and then doing a copy paste. And so there's no security around that or governance. And the developer, maybe if they're really concerned or very focused, they may read it, but frankly, a lot of times they're not even going through the code that was written. They're just pasting it into whatever app they're building.
Yeah, definitely. Now you can see some of them are reviewing some of the code because they're still in the place of establishing trust with Gen AI and if it's bulletproof or error-proof. The trend is that you will see less and less developers reviewing the code and just take that as is, the more it gets better, which means it will be much more error-prone to big security mistakes. So if security teams today put a document of here is the security standards for APIs and how it should be built, they're training or at least try to communicate and train developers. It doesn't help the LLM that you prompt and says create an API. So what will happen, what we foresee, that the growth of APIs will get significantly accelerated. The number of changes to an existing APIs will significantly get accelerated. And the number of misconfiguration gaps in APIs and vulnerabilities will go through the roof just because LLM is not trained to really try to build it securely, definitely understand the business context of this application and how it should be built. So every time we had in technology in general, a quicker way to ship software in whatever form. It used to be containers, right? And it still is that containers help you to ship code faster. Very quickly, you need container security and workloads. Like it opened up a lot of attack vectors. And that this is yet another one and a big one that basically all your code is not being coded by you as the company, right? And now you have security team that needs to govern something that another code creating code, right? AI and LLM creating code. So it's definitely making it very hard.
Why would you, if it can make you more efficient? I mean, you're absolutely going to do it, right? If you can produce the same or equal amount for less effort, you're absolutely going to use prompt an AI tool to create it. You're going to be able to deliver applications way faster than you have before. But I think, like to your point, what this is saying is it's going to accelerate the number of APIs that people see. They were having a hard enough time in the past even keeping up with them to make sure that they were secure or adherent to policy. This just makes it almost untenable, right? Like, how do you possibly keep up with this unless you have something that's automated to a degree, but that's checking to make sure? Because it's almost like once you get hooked on that speed of development, you can't go back, right? And so it's going to be accelerated. So you have to have some sort of security in place to be able to manage it, right?
Yeah, completely. I think, again, anything that accelerates technology creates always kind of security follows innovation, right? But there is a lag. And this lag between the innovation curve to the security curve, there is a lag. And the lag is exactly the security opportunity or the threat or the attack vectors, right? And this is where exactly we come to fill this gap, because you don't want to slow down because of security. You want security to be an enabler, not a blocker. So the question is not how we prevent developers to use generative AI or LLMs to create better code or to ship faster or innovate faster. The question is, how can we make it in a secure manner? How can we have automated tools that can be at the speed or moves at the speed that developers are pushing code and changing and creating new APIs? And, maybe, I don't know if we'll talk about in this episode, a different episode about AI agents and how does that going to fit into the world, because AI agents are using APIs to communicate or integrate with all these systems. So again, it's creating a huge attack vectors for companies that they are bringing in so much of code that is very intelligent code that has a lot of access to so many different systems, but without the governance and without the security. And I think we will see some major incidents in the next year or two because of that will provide a lesson, if you will, on how you can do it in a safe manner or how not to do it.
Agreed.
But the first phase is always innovation first, and then we'll see the ramification of it.
So let me segue a little bit with this. So it's happening now. People are using the Gen AI tools to create code. You do hear, well, on the security side, let's use, and I'm going to broadly use the word fight, but it's not really like that, but use AI to fight AI, right? Like, how can you leverage the AI in security? And maybe talk a little bit about like what we've done within Salt, where we leverage AI, where it's delivering some sort of either improved security or better customer experience for people that are using Salt.
Completely. By the way, we are like any company that ships codes as well and innovate as well. We are no different, right? So we need to use AI to build better software and to fight AI, if you will, or to secure AI. And also use AI in order to help our customers take advantage of our data, because again, the more data you have, so the more APIs you have, you want to use AI. So that's one aspect, right? We embedded a lot of LLMs into our product to make it easier to consume the information. So instead of you need to go through thousands of events, of anomalies that happen. For example, we used attackers, we call it Pepper, that are AI agent or AI assistant that basically takes and summarizes for you. This is what happened over the course of thousands of security events. So for the SOC analyst, it will be very easy to understand what's going on instead of doing hours or days of research on doing an incident response. They can simply go in and then they can get a quick summary in 2 minutes to understand what's going on. So essentially, we use AI for efficiency. So make it easier to consume and act upon our findings. That's one aspect for attackers, for discovery, for posture. The second aspect is how we leverage AI to innovate faster. We use AI to better classify APIs and have accurate inventory of APIs. We use AI how to train our models to know what's normal for API activities, what data should be pulled out, how much of it, in what pace, in what sequence of calls, and so on and so forth, to really base on what is normal behavior. This is something we've always done for the beginning of the company, but obviously we're taking advantage of the latest innovation in AI and bringing that in so our customers knows that the latest and greatest in the market is used to protect them against the latest and greatest threats, right? So we always want to make sure this equation is balanced.
So it's like, I know that in the product, there's the prompts, and again, Pepper is our AI agent that we use, and Pepper will give recommendations. So within our threat module, say, here's what you should do as an analyst. But this other piece, and you touched on it just lightly, and maybe we'll close on this idea of using AI to understand attacks, but in particular, there's a really important word. It's the intent, right? Because when you think about what we call broadly AI calls in an organization, it's billions. You can't count the number of, like manually, you couldn't count the number of API calls, but it's billions a month. And some companies have tens of billions a month. to be able to analyze that for intent as a person is practically impossible. But AI can be used, which I think we'll use it, and maybe talk just a little bit more on this, Roy, is how we use it and how that we have that understanding of what the intent is, and it's a big differentiator for us. And we have a lot of effort that's gone into that and a patent on it. But maybe talk just a little bit more about that one.
Yeah, so I think let's start with setting up the challenge with specifically APIs and threats. The challenge with APIs that APIs is a lot of abnormal activities or anomalies, if you will, that are actually benign. And why is that? Because you have developers try to integrate to APIs and not necessarily read the documentation really well, had mistakes. You have partners that may be excessively using your APIs that creating traffic spikes. And you have different version of applications connecting to your backend. So when we say APIs, we mean any type of API. It be mobile apps, web app, microservices, company to company, machine to machine, anything that exchange data. So what we found when we create our anomaly detection or a machine learning to baseline normal behavior, realize the output has a lot of anomalies, but most of them are benign. So we actually did the research and we found that almost 99% of anomalous users are actually benign users. They're not trying to attack you or attack the company or find vulnerabilities. They're just not using API correctly or using it in a way that is just the 1%, right? The top 1% of the rest of the users. But 1% of tens of billions of calls, it's a lot.
It's a lot, right?
So what we did with LLM, with the agentic AI, really is to build an intent engine that takes all these anomalies and contextualize them. So when we look at an attacker or a user, it says we don't know it's an attacker. We know it's an anomalous user, but we want to make this decision. Is this anomalous users that actually are looking for vulnerability? Is this actually an attacker with bad intent or malicious intent? Or is it just, anomalous but benign? And this layer of intent engine that we've built in our big data help us to contextualize it, to look at the sequence of events over time, and to understand if there is malicious intent here. One classic example I'll give you just to make sense of it is typically an anomalous user will do the same anomalies, quote unquote, or mistakes again and again. So they'll do the same repetitive mistake on this API because why? Maybe they have code that using the API in a very excessive manner. An attacker on the other end has a lot of diversity. They will try to open one door, one API, it doesn't work, they'll go to a different APIs. So we'll see a diversity of the type of manipulations versus anomalous users that typically have much more repetitive pattern. That's one example to how you can distinguish between benign intent or good intent to malicious intent.
Yep.
So this layer for us reduced 99% of alerts to our end customers. So instead of you getting, as a customer, 100 alerts, you'll get only 1 or 2 alerts, which are the real ones.
Yeah.
And I think this is where AI really helps you find the needle in the haystack, not as a catchphrase in the real world, and contextualize all of this data and give you just what you're looking for.
Yeah. Well, and the ability, I think one of the things that you intentionally did, which is very different than any of the other solutions out there, because of this approach that you just explained with an attacker, where they may try something and then maybe they get distracted and then they come back, or maybe they're not distracted, but they come back and it's like a day later or 2 days later, or maybe a week or 2 later. You need to be able to connect all those data points. And so you have to maintain that data or that intelligence over a period of time to see this. And it's something that we do, that you build the product in order to do that, so you can see that intent. Because if you take too narrow of a snapshot, or you have too narrow of a window, everything may look fine. But then if you expand it out, you realize, oh, actually there is something going on. And that's where, as you combine that concept with using AI, it gives you a better solution and really higher security for our customers. Okay, I'm going to wrap us up. But thank you again, Roy. This is always interesting to talk to you. For everyone else out there that's listening, thank you for joining today. We do these every 2 weeks, so please come back and check every 2 weeks. And if you want more information, you can always go to salt.security, and you'll find everything you need to know about API security. Thank you again for joining, and we'll see you in 2 weeks.